No, but it matters to the influencing factors, as I was just mentioning in the very first, I mean, or rather, say a couple of slides. What are the influencing factors? One is that the vibration due to ground excitation. If you say that right from space, etc., finally you would have the a ground station or somebody working at the ground. For instance, aviation, you have ATC tower and other electronic systems. If they don't function, then you will have a problem to the aeroplane which goes at a higher altitude also. So these matter a lot for the uh, what do you call the station or grounded, the mobile stations or the other electronic system which would be controlling the rest of the electronics somewhere around in the remote locations. So ground excitation is basically like an earthquake. So there is not necessary that all the times earthquake. What if you have a heavy machinery closer to your room and your ground is not, or the flooring is not really made, and you will always see that these guys gets jacked. For instance, you try to run it a heavy generator closer to your residence or maybe in an office, and you go and try to be there. How annoying is that? And the biggest problem is that if you try to keep your mobile or something else, and they try to saturate all your what do you call the soldering and other brittle material inside your electronic system. So brittle material is again your PCB made of FR4 and all. So that's the reason vibration is always a nuisance for the electronic systems. And the vibration come over not only about the ground excitation but on account of the movement on the roads and the tracks, aerodynamics and the waves, etc. So I don't know how these guys do that. Amazing. We need to thank them. For instance, um, the road profile, if it's not really good, high terrain, especially in the regions where you have the bad profile, the road profile also. And they keep on exciting that system. And if the electronic system doesn't really, function properly, and nowadays, because the electronic is a guy, our electronics box is the one which is a brain of several of these control systems, and it doesn't really work out. So the vibrations, it causes on account of the roads or on account of aerodynamics or on account of the excitation. Vibration is an unwanted thing for the electronics. The next comes the cold and hot weather conditions, as briefly explained earlier too. This is never ending story, and temperature is always should be within the limitation of or within the limits of the electronic systems or the electrical system. Humid and dust environment, there are a lot of stories or the white papers and theses, patents which have been there. Very several of my colleagues too, they have produced about the dust environment. There's always a challenging that dust comes and it will try to create a problem for your cooling systems, and that's how indirectly they'll cause a big problem over there. Solar radiation, the hazard environment, any chemical around surrounding you, there will be like a corrosive element for your heat, what do you call heat exchanges, etc. Will be a problem for that. And solar radiation, and if it is inside, absolutely, we don't talk about the solar radiation. There is some other radiation, of course, radiative heat transfer in the natural convection system. That is also a part of it. But solar radiation, as such, unless otherwise they get exposed to, we don't talk about that. But for many of these applications, at least 25 to 30% or so, they get exposed to the solar, all these electronic systems or so. So not directly that a PCB or with the electrical system it would be exposed to the solar, but indirectly also. For instance, if it's in an enclosure, and the enclosure it gets the high heat flux ranging from 800 to 850 watt per meter square till go to 1440 watt per meter square of the heat flux onto the surfaces. They'll try to radiate back onto your electronic system, and they cannot afford to function under these conditions. So what should I do that when I have such a bad influencing factors, and what should be my design objectives, and try to say that yes, I would have done that. this whole process of it, or others say task accomplished, mission accomplished, and what is that I made it. So unless otherwise we have design objectives developed properly, then any attempt towards your design enhancement will bear um, less or minute productivity. So the fruits born from these all the efforts would be minimal. So that is what you need to do. That sometimes we would be on toast to do some fancy thing, but if that's an expensive one, our DFX element, which is called design for excellence. So excellence and the cost is one of them. So design for cost will not be met over there. So that needs to be carefully done that before we try to address these objectives. So what are these generally objectives? So meet the specific functionality. So DC-DC converter or a signal or a mobile or maybe a router or an imaging processor for a healthcare industry or in a avionic industry. First understand the specific functionality of it. That is at most required. That will try to give you the challenges, also learning that. Then successful transmission of data signal without any distortion. That's what exactly we do that. So we have generally the voltage and the signal. I mean, in a crux, if you look upon that, what exactly is it all about the functionality? Either the signal or the data, any without any distortion. That is how the total objectives are. Then no degradation in current voltage levels. It may be within that, but as you pass on with the time, if a customer says that I would like to have this unit installed and this would go and the life of my product is for about 7 to 10 years or maybe sometimes 15 to 20 years or so, and if there is any degradation of the performance of that, so the design for reliability DFR is not really met. So one of the excellence, what do you call engineering or engineering is not met. So that is where you need to really look up on that. So I would be able to make my cooling system. For instance, you made a fan with a filter, etc., because to avoid any dust. But the fan may be really good, great. But what about the air filter? So you need to understand that before you try to go for replacement of that or a serviceability of it, that how many hours successfully it would do that without degrading the performance of it. That is what it comes out of the degradation. And what about the cooling system or the liquid cooling system? Same thing problem. If you're using water, ethylene glycol water or propylene kind of a thing, so not that you try to fill in all these guys within the cold plate and they would try to take care of that. No, there would be always a degradation. So that's what you need to estimate, that what would be your cooling system, and based upon that whether the objective is met or not. The reliable performance at specific conditions. So that is what all about the design for reliability we talk about, saying that reliability need to perform in a sense no failure within the specific time limit, and moreover performing at specific conditions. So I would like to not replace any of my fans or cooling systems for the 10 units which I have installed somewhere. So one of them gets filed over a period of time like 5 years, which you had really mentioned earlier, whatever you have promised to your customer, saying that, sir, I can really meet this requirement, saying that they would say that, hey, guy, I cannot replace all the fans or the cooling systems once in a while, every year, not possible. That's a very expensive. Okay, then what should I do that? Fine. Um, one failure over 3 years is okay for me, he says that, because that's here the maths or the economics work for him, and you should go for high reliable components, etc., to ensure that no failure would occur under these specific conditions and within this specific time limit. The next one is the cost effective and optimization designs. This is exhaustive engineering. Today cost is at most critical, because our bonuses, our salary, or consultation fee, or whatever it is, it will keep on increasing. But the cost to the material, through the material or maybe the design, doesn't really reduce that, right? So that is a bigger challenge for that. So apart from the material and the logistics, and we also have the design. The design cost normally ranges from 12 to at most 16%, but the rest of things is all towards your material, logistics, etc. And that's the reason they would always hate if you are spending more money. But this 10 to 12% would affect the entire product. So it's very critical, but at the same time, the cost to deliver. And also, if I'm spending for about 35% of it on material itself, um, profits will try to decline. So I like to make some, pick it up some parts, or others say some techniques are very fast, designed to, what do you call that, cost, designed for manufacturability to that. And if it's really fancy, but it may be really yielding very good performance, but the cost is like twice, then that would try to demoral the whole cost, what do you call the analysis also. So that is how really important that you also need to address this cost issue and deliver on time with quality. The fans fail, or your duct gets clogged, or your liquid cool systems fail, and the simple is that even there is a heat treatment, or rather say the coating on your heat exchanger is lost over a period of time very quickly. That's a big problem for them. That so you need to enhance about the quality right from at the design stage, then the objective is met. And what are the design methodologies and processes we have it? One is that, of course, system design, as I was enhancing about that. It's all the culmination of interdisciplinary design. One of the examples I would like to put forth, apart from the normal things which we are talking about, the electromagnetic interference, electromagnetic compatibility. What if the cooling system is really good? You had enough ventilation for your cooling system, everything is working, and you put it across in your anechoic chamber, and suddenly the EMC guy says that we failed the EMC. And you would ask him that, okay, what do you want? What best can be made? Hey guy, I'll have to seal this guy to a larger extent. Then as a thermal management engineer or cooling guy, you would say that if you try to close down all these doors for this guy, how am I going to cool this one? Yeah, this is where the conflict comes between the thermal guy and the rest of the electromagnetic interference or the electronic guys. They say that they together you cannot, so there is something called optimization. Well, you'll have to also address that issue, how much shielding you require it, and how much of the opening you can afford, and based upon its a clock frequency or exposure, radiated emission, conductive emission, lot many other things come over as you try to proceed and try to put your heart in this one. And as I told you, that design for excellence, several things. One is the assembly, manufacturability, inspection, cost, testing, serviceability, reliability. There are several other things. For a guy who is at the space research, etc., assembly may be very, very, what do you call, tedious, but he's okay with that because he's more interested in about its reliability. And everything is fine, but it is meant for some research to read certain, parameters. So this is really important for him. And manufacturability for all the cases, most of the cases. And DFMEA, that's the one which will set that the shortcomings in that. So you need to be very honest, very, very honest, saying that, okay, yeah, these are the failures I would foresee that. Only then there is an opportunity to revamp about your design synthesis as well as the quality of it. Oh, finally, the verification and validation. You would say that, okay, how many protos I require, and this is what exactly. And I would say that these are the tests. If I try to do that, I'm done. So I'm very clear about this will be functioning that. So that is what you need to go with the qualification tests. If the customer asks for that, okay, you try to pass it on, I'm happy. Otherwise, you'll have to make some mathematical models to see that, okay, what do I try to extrapolate it? Otherwise, you'll have to do some reliability tests and or field tests. So straight away put it across in the field test if it is of a very low order, what do you call the cost. If the testing would be of 10 folds of whatever you have produced, then it makes no sense. So it's better that, okay, you would say that I can afford to do the I mean, I can afford to multiple Pro Tools or whatever could be, but I would like to go for a field test. And I said, okay, fine. The customer would be happy rather doing that. And what would I have in general, the course contents? If I mean, you are interested, it will have application, requirement study, resources, cost and scheduling, then design constraints and concepts. So if you're already from cost and scheduling or you are really well versed of that, then this will enhance in fact. So there's no great technical involvement in that, but it's more the involvement is what about the cost and scheduling it. It's not about the technology, rather about it's the involvement of that. And design constraints and concepts. So how good your concept, it's not the number but the quality of it. And electronic, electrical, and battery components and their thermal behavior. So that's where what do we talk about? We talk about electronic and electrical and naming quite number of times per slide, and what type of a packages, etc., components and their behavior also is what we'll try to see that in the codes. And finally, the overall thermal management or system design. So, from system design perspective, not just focusing upon the component, but rather say at the system level, what are the things we need to look upon that while going for the optimization of it. And design processes and the methodologies that include verification. And finally, one would ask that, hey, where do I try to procure this one guy? It's really good, but how do I make it? So it is also a managerial kind of an aspect, or rather say organizing yourself, trying to identify a right manufacturer for you to make that part of the component, realizing, as part of your electronic or electrical unit. And finally, the procurement of goods. So you say that I created a wonderful cooling design or etc. Sometimes even people do that good material, but if it's taking more lead time or the long time to produce it, that becomes a tougher decision for the business. So these aspects you need to do that. And validation, prototyping and testing, don't keep on testing it and repeating upon that to realize about the same parameter. And you'll have to qualify the design for production finally. Okay, not necessary that you try to keep your statement heard by several guys at the prototype. And feed failures and the mitigation. So in case it's the job is not over after delivering it, sometimes you will let, if you're involved directly or indirectly, field failures, it's better that you understand the root cause analysis and try to look upon the improvisation. So any failure at the field results in two ways. One is that they'll be risky, um, what you call economically, but the other one is that it's always an opportunity to learn and try to improvise that. And finally, the what exactly you address it, the thermal management system for the unit which you are trying to put it across to your team. About that's about the project work. um, Technologies, as I had spoken multiple of things, this would be very, I mean, what do you call the heat sinks, the heat pipes in the laptop. You will have the centrifugal blowers, etc., the cold plate. It's some of these ones you Google it, or rather say you look upon in your own industry or your neighboring, the place or so, you'll find all these guys. So these are all just limitation of that. And finally, the opportunities. What is that for me? As I was telling you that, as a person, if you look upon that, it's only the based on application as defined only. So there are numerous industries that require thermal management experts. So there is no doubt about that. But component manufacturing or product development or testing, program management, or these are the domains where you would like to be part of it. Yes, these are an opportunities in that, and there is no limit to innovative designs and technologies at all. So absolutely, it's like the sky is the limit for many of these the wonderful technologies. And some of them picked up by my team, in fact. So you would see that Google it, or any industry that makes electronic, that's there is an opportunity for you that. So the sky is the limit for you. That be it communications, be it the component manufacturing, or maybe the marine, the ship industry, several of this one. So this is what it is about that.